Welcome to the DIY Honda Garage channel. This presentation outlines the P0157 Diagnostic Trouble Code, DTC, specifically related to the front secondary heated oxygen sensor, secondary HO2S, for Bank 2, Sensor 2, in the Honda Accord models ranging from 2012 to 2017. The DTC is triggered when the circuit reports a low voltage, indicating a potential issue with the sensor or related components. The oxygen sensor plays a crucial role in monitoring the oxygen density in the exhaust gases, which is essential for optimal fuel combustion and emissions control in the vehicle. When the voltage output from the sensor drops below a certain threshold, it can lead to performance issues, reduced fuel efficiency, and increased emissions. This DTC requires careful diagnostics to identify the underlying cause of the fault, which may include wiring issues, sensor failure, or problems with the powertrain control module, PCM, itself. The troubleshooting steps outlined will guide in accurately diagnosing and rectifying this issue to ensure vehicle performance remains at optimal levels. The front secondary heated oxygen sensor, HO2S for Bank 2, Sensor 2, is designed to detect the density of oxygen in the vehicle's exhaust gases. This sensor is primarily located in the exhaust system, downstream of the catalytic converter. Its role is to convert the oxygen density readings into electrical signals that are sent to the powertrain control module, PCM. This data helps the PCM adjust fuel injection and ignition timing, ensuring optimal combustion. When the sensor outputs a voltage that hits a specific low threshold for a designated duration, the PCM recognizes a fault, subsequently storing the P0157 DTC. This creates a situation where the vehicle may not perform efficiently, necessitating thorough diagnostics to identify any faults in the sensor or its wiring. Understanding the location and function of the secondary HO2S is crucial in effectively troubleshooting and resolving the DTC. Several possible causes can trigger the P0157 DTC, which include short circuits in the wiring associated with the secondary HO2S. For instance, the SO2B2 line could have a short to ground, which would affect the sensor's voltage output and lead to erroneous readings. Another potential issue could involve the SO2SGB2 line, similarly exhibiting a short to ground condition. Internal failure within the powertrain control module, PCM, is another significant concern, as the PCM is responsible for processing the signals from the sensor. Additionally, a malfunctioning PGM-FI sub-relay may also disrupt the supply voltage to the sensor, leading to low output readings. Each of these causes must be examined thoroughly during the inspection process to determine the exact fault leading to the DTC. Accurate diagnostics are essential to rectify the underlying issues effectively. When encountering the P0157 DTC, several symptoms may become apparent, primarily indicated by the activation of the malfunction indicator light, MIL, on the dashboard. This warning light serves as an alert, signifying that the engine management system has detected an issue. Additionally, drivers may experience decreased fuel efficiency due to improper air-fuel mixture adjustments resulting from faulty sensor readings. Increased emissions can also occur, leading to environmental concerns and potential failure in emissions testing. The first troubleshooting step in diagnosing the P0157 DTC involves starting the engine and maintaining it at a steady 3,000 revolutions per minute, RPM. This should be done without any load, meaning the automatic transmission should be in park or neutral, or the manual transmission should be in neutral as well. Holding the engine at this speed ensures that it operates in a controlled manner, making it easier to observe any abnormalities in the sensor readings. As part of this procedure, technicians should pay attention to when the radiator fan engages, which signals that the engine has reached a certain temperature threshold. This step is essential for confirming that the engine is operating under diagnostic conditions that reflect the typical driving scenario. Skipping this verification step may lead to overlooking underlying issues that arise under normal operational conditions. In the second step of troubleshooting, a Honda Diagnostic System (HDS) tool should be utilized to further analyze the vehicle's systems. While no specific commands are detailed for this step, utilizing the HDS enables technicians to monitor real-time data and check for fault codes or abnormalities in the secondary HO2S readings. It allows a deeper dive into parameter monitoring, confirming whether the readings align with expected values based on the engine's operational state. Changes in readings from the secondary HO2S while the engine runs can provide insights into possible wiring or sensor malfunctions. Thus, standard diagnostic tools like the HDS play a critical role in effective DTC resolution. Staying attentive to the data provided by this tool aids significantly in identifying whether the issue lies within the sensor or elsewhere in the system. Upon completing the necessary repairs associated with the P0157 DTC, it's essential to perform final verification steps to ensure the issue has been resolved. Start by clearing the DTC from the vehicle's memory, using appropriate diagnostic equipment. Following this, conducting a test drive is crucial to confirm that the repairs were effective and that the malfunction indicator light, MIL, does not activate during typical operation. This step allows for observing the vehicle under real-world driving conditions, ensuring that the oxygen sensor functions correctly and responds appropriately to changes in the exhaust gases. If the MIL remains off post-drive, it indicates that the repair was successful. Ensuring this final step is executed thoroughly provides both the technician and vehicle owner with confidence in the longevity and reliability of the repair. While not specifically detailed in the original diagnostic text, implementing preventive maintenance is vital in preventing P0157 and similar DTCs from occurring in the future. Regularly inspecting the oxygen sensors is essential, checking for signs of wear, corrosion, or physical damage. It is equally important to assess the wiring connections to ensure they are secure and free from damage or shorts, which can adversely affect sensor readings. Additionally, maintaining overall engine health plays a substantial role in sensor longevity. This includes timely oil changes, air and fuel filter replacements, and addressing engine issues promptly. Awareness of the wear and tear on these components can save time and money by preventing more severe mechanical failures. Consistently following preventive maintenance measures significantly contributes to optimal vehicle performance and emissions compliance. In conclusion, understanding the implications of DTC P0157 is crucial for vehicle owners and technicians alike. This specific DTC, indicating a low voltage in the front secondary heated oxygen sensor circuit, can lead to reduced performance and increased emissions if not addressed. Following the precise troubleshooting steps ensures that potential causes are explored thoroughly, allowing for accurate diagnosis and effective repair. Furthermore, performing preventative maintenance can significantly reduce the occurrence of similar faults in the future. By recognizing the signs of malfunction and addressing them proactively, drivers can ensure their Honda Accord remains in optimal operating condition. Overall, a comprehensive approach encompassing diagnosis, repairs, and routine maintenance goes a long way in preserving vehicle reliability and efficiency. Please like and subscribe to the channel. See you next time.